Good morning, everyone. Good morning, Doc. I am the first reporter from Group 2. The first topic that I'm going to discuss is about capacity management. Now, let us know first what is capacity. It is the maximum output that a business can produce in a given period with the available resources. It is usually measured in production units. So, for example, sa car manufacturer, 1,000 cars per month. Capacity is linked to workforce planning. For example, by working more production shifts, kanang mag-work overtime, so mo increase ang capacity. Next, capacity needs to take account of seasonal or unexpected changes in demand. For example, ice cream company needed to quickly increase capacity during heat wave or during summer. Another example is the increase in demand of alcohol and face mask during sa pagsugod ng pandemic. Now, what is capacity management? Capacity management is the ability to meet a customer's requirements with the available resources. Example of resources at hand, kanang machineries, factories, raw materials, labor, etc. Capacity planning. It is the process of determining the resources required to meet the priority plan and the methods needed to make the capacity available. It is done based on projections for future product demand, labor, and equipment requirements. Let us consider a scenario that our demand is 500 pizzas in a day. How would you plan your capacity to make your business demands? Let us do some quick checks to see if we can meet the demand. So as you can see here in the picture, the oven is one of the resources needed ng isa ka pizza company. So, is my oven capable of preparing or delivering 500 pizzas? So, managing the oven setting would help as we are time-bound. Or maybe, mag-purchase of kanang additional oven para ma-accommodate ang 500 pizzas. Next is the number of associates to help facilitate preparation and delivery of 500 pizzas. And then the ingredients you prepare to make 500 pizzas. So those are the things that we need to consider in capacity planning. Now let us proceed to the next topic, which is the decision tree. Decision tree is a schematic representation of alternatives available to a decision maker and their possible consequences. The term gets its name from the tree-like appearance of the diagram. So here is an example of a decision tree. Square nodes denote decision points. So this is the square node. This is the decision point. Circular nodes denote chance of events. So A, B, and C are the chance of events. Branches leaving square nodes represent alternatives, and branches leaving circular nodes represent chance of events. So for each decision, choose alternative that yield the greatest return or lowest cost. Now let us cite an example. A manager must decide on the size of a video arcade to construct. The manager has narrowed the choices to two, whether to build a large or a small arcade. Information has been collected on payoffs, and a decision tree has been constructed. The decision tree is analyzed to find out which initial alternative should be chosen in order to maximize expected monetary value. So this is the decision tree nga gihimo ni manager. The dollar amounts at the branch ends indicate the estimated payoffs. So here are the estimated payoffs. These values are in thousands. So for example, if the initial decision is to build a small facility and it turns out that the demand is low, the payoff will be $40,000. Similarly, if a small facility is built, demand turns out high. If the demand is high and later decision is made to expand, if the manager decides to expand, the payoff will be $55,000. The figures in parentheses on branches leaving the chance nodes indicate the probabilities of those states of nature. So here, 0.4 and 0.6. Hence, the probability of low demand is 0.4 and the probability of high demand is 0.6. Payoffs in parentheses indicate losses. Now let's analyze the decisions. First, we need to determine which alternative would be selected for each possible second decision. So for a small facility with high demand, there are three choices: to do nothing, work overtime, or to expand. So because expand has the highest payoff, you would choose it. And then indicate this by placing a double slash through each of the other alternatives. So from here, we put double slash, and sa overtime pod, we put double slash. Similarly, for a large facility with low demand, there are two choices: do nothing and reduce prices. So you would choose reduce prices because it has the higher expected value. So a double slash is placed on the other branch. So we put double slash here. Okay. Next is to determine the product of the chance probabilities and their respective payoffs for the remaining branches. Let us solve the first decision, which is to build a small arcade. For the low demand, we multiply the state of nature, which is 0.4, by the payoff, which is $40,000. The result is $16,000. And then for the high demand, if we multiply the state of nature, which is 0.6, by $55,000, the result is $33,000. We chose the expand, which is $55,000, because it has the highest payoff. So always choose the highest value. Now let us proceed to the second decision, which is to build large arcade. So for the low demand, we multiply 0.4 by $50,000, since $50,000 has the highest value. Diri gani sa reduced prices. siya ang highest value. So 0.4 by $50,000, the result is $20,000. And then for the high demand, we multiply 0.6 by $70,000. The result is $42,000. Okay. Next, lastly, we determine the expected value of each initial alternative. So to solve for the expected value of initial alternative, we must add the results of each alternative. So for the small arcade, it's 16 and 33. The sum is 49. $16,000 plus $33,000 is equal to $49,000. So for the large arcade, it's 20 and 42. The sum is $62,000. Hence, the choice should be to build the large facility because it has a larger expected value than the small facility. So here are my references. Thank you for listening.